Okay, 21. In order to be accepted into a certain top university, applicants must score within the top 5% on the SAT exam. So I think for this problem, you need to know that the SAT exam is normally distributed. Scores on the SAT are normally distributed. So this is a normal distribution problem, right? It's a normal distribution problem. We need the top 5%. Given that the exam has a mean of 1,000, that's the population mean, population standard deviation of 200. What's the lowest possible score a student needs in order to qualify for acceptance? Okay, so let me draw this. Here's our normal distribution. Our mean here is in the center. And so in order for a student to be accepted, they need to be in the top 5%. They need to be here. So this is 5%. Or 0.05. Right? The area of this small region here is 0.05. This is 5% of the entire area of the distribution. Okay? So you need to be in the top 5% in order to qualify for acceptance. That means everybody else is here, which is 95%, right? Or 0.95. 0.95 plus 0.05 is 1. 95% plus 5% is 100%. So you need to be here in order to be accepted into this university. Now, what does this mean for us, right? What I think this means is, since this is a normal distribution, I can find this z value here. I can find this z value that yields the top 5% of the population. And I do that by going to the normal distribution table. Remember, that table gives us the area to the left, right? And here's the area it's going to give us. It's going to give us this area here. It's going to give us 0.95. So I'm going to look at the table for the area of 0.95 and find the z value that gives me that. So again, I'm going to the z table. I'm looking for the area, so I'm looking in here for 0.95, and this will tell me the z value that yields 0.95. It's not here. It's going to be on the positive side. It's going to be on the positive side. So I'm looking for as close to 0.95 as I can get. 0.95. Let me go up so I can see the top. Yeah, 0.95. It's close to it. Look, look, look. Here's 0.9495. And here's 0.9505. So these two are both the same distance away from 0.95, right? Same distance away. 0.95 is right in the middle of these two. So I'm going to use the one that has a larger absolute value. So I'm going to use 1.65. 1.65. 1.65 is the z value that gives me there. All right, 1.65. Okay, so this z value here is 1.65. Now that doesn't answer the question, because the question is saying what's the lowest possible score a student needs to qualify for acceptance. The lowest z-score they can have is 1.65. But what is that in terms of this problem? What is that in terms of real values? Go back. What am I looking for? Here, the normal distribution. Here's the standard score. So the z value is the x value, the real life value, minus the mean, divided by the standard deviation. So z equals the real life value minus the mean, divided by the standard deviation. That z value, I know what it is. It's 1.65. Equals, I don't know the real life value, that's what we're trying to find. The population mean is 1,000. Divided by the standard deviation is 200. I can actually cross multiply here. So x minus 1,000 equals 1.65 times 200, right? So move that decimal point 2 places over. 165 times 2, that should be what? 330? 1.65 times 200 is 330. I add 1,000. So X is 1330. That's the score, the minimum score that a student needs in order to qualify for acceptance into the university.